The lecture of today is about epidemiology and statistic. It's just an introduction, by the way. My name is David Yanlu. Let's look at this friend of ours. He's also a public health nutrition consultant and recently got a job as a consultant in Asker and in Shi and in Barum in different institutions. And then the first thing that come in his mind is to know more about those counties. So what did he just search in the internet and found this website, Norwegian website for the statistic, which called the Statistics Central Bureau. And this is a very useful website, and then you can use it to find a lot of data generally about the population. And then he found that the population on these three counties, and the highest is belong to Barum, and the lowest is 29,000 something belong to Shi. By looking at the population, he got some information which is not enough, so he decided to search more and thinking about that. Let's look at the population by age groups. It was possible to look at the age groups, the four predefined age groups in this website as 0 to 5, 6 to 15, 16 to 66, and 67 plus. And he found the numbers out of those the age groups in each county. But looking at this table and look at the numbers don't give us any clue that how close or how different they are. So he decided to use to check the percentage of those or proportion of those populations based on the age group, and he found out that, as you see, they are exactly the same. For example, here in Shi, if you have 0 to 5 years old, that's 8%. It's also 8% in Barum and Oscar. And this age group 6 to 15, it's 14%. This big age group from 16 to 66 is about 65% of the whole population in each of them, and then about 30% of the population will be there. Then again, because these age groups are very different intervals, 0 to 5, 6 to 15, and so on, he was thinking that what if we look at the all ages? So instead of looking at age as a categorical variable, he decided to look at it as a continuous variable. The first chart he got from this online tool website, in this website, was the making a histogram, as you see. And this histogram, the first one is belong to Barum. And as you see, the y-axis is the persons or the frequency of the people, and this axis we have the just ages. So each bar represents one age. For example, here we have about 2,000 people in age group 43 that they are living in this area by 1st of January 2015. You look at this and there's a pattern. As you see, it's just increasing here, and then it started to decline by the age of 29 and it increase again. If we look at this age distribution for the count of Shi, we see that it's also have the same pattern. And then if you look at the Oscar, and then it's also the same pattern. So there is a decline here that the people in age around 18 up to age 29, 30, they are moving out, or they are become less. So he was thinking that why is it declining? So the first thing that's come in his mind, as we also think, that maybe those people are moving to other cities for education, so they are immigrating out of these counties and go to bigger cities like Oslo and so on. So in this case, if we have the bar chart of the Oslo, we should have a increase in the number of people in these age groups. And by looking at the same website and looking at the Oslo, he just found out that that's correct, and there is an increase or a peak here for the age group of 18 to 29 here, and probably this is due to people who go to those cities for education, and or maybe some of them go and leave there, and maybe some of them then start to come back. This is why we have the second peak here to live in their own city. but it's not clear. It's just a general assumption. It's not something that we can swear on. It's just some data that we found out. But if we look at it, it's actually the way we are thinking in any kind of research. The first thing we found out, it was a phenomenon, it was unusual observation, it was this declining, and then it was a research question that why is it happening, and then we had a hypothesis that maybe it's due to immigrating to the bigger city. And then we had our time, and then we checked the Oslo and said, yeah, maybe we are correct, but it's not finished here. So it will be continued, but we have some ideas. Usually, this type of observations calls correlational or ecological observation, that we are looking the total population and one phenomenon, that how they change or related to each other. What he did actually, he studied upon the people. We call it the epidemiology. It's coming from the words epi, demos, logos. It means studying. It means upon, epi, upon, demos, people, logos, and knowledge. The knowledge that you get by studying the people. And also, he used the numerical data to show the status of the people, and we call it the statistics. So it always comes something like that. For example, he now said, I wonder how the distribution will be among the genders if we look at the age groups and genders. But before that, let's look at the history of the epidemiology a little bit. We go back to the time in London in 1854, when it was another outbreak of cholera killing the people. At that time, people have the only source of water from the water pumps in the streets. So they should go and pick up the water and go home and use it. And when this outbreak of cholera happened, it was a young doctor, a very clever doctor, it's called John Snow, and he did something new. He started to map the disease, the death of cholera, and he put those red dots on this map, as you see, for each person who died. And then he found out that this concentration of the red dots is around the Broadwick Street. And at that time, nobody knows the cause of cholera. Cholera is a terrible disease. It's caused by bacteria, and it affects the intestine, and it causes a watery diarrhea, huge watery diarrhea, and then the person get dehydrated, go to hypovolemic shock, and die very fast. And at that time, they didn't know how to treat it. And even they call it the blue death, because the person color changed to blue. It's also due to the hypovolemic shock, losing a lot of fluid and electrolytes. So he just thinking what those people have in common in this area of the concentration. And then he had some ideas about, for example, food or so on. At that time, they were thinking that the diseases are transferred through the air, which called a theory of the miasma. And he also think about the, for example, buildings and so on. But in the end, he found out that, okay, maybe this is through the water, because the people in this area just have access to water through those water pumps. And then here, the water pumps in Broadwick Street, is the water is just coming from the company called Vauxhall, and the other, for example, from the Lambeth, which has less concentration of this cholera. So what he was thinking, that there is something wrong with the water, and he wanted to find out what's the problem. And in the end, he just get the authorities to remove the handle of this pump, and then he found out that yes, there is the problem that coming from there, because the epidemic of the cholera was stopped at that time.